people use bamboo to construct buildings up to 2 stories, we feel terrified and concerned. This arises from the misconception that bamboo has a higher tensile strength than steel. It is a false information. According to that video that engineers advise their clients, I'm not here speaking on behalf of engineers, but I can authoritatively say that any engineer who has been trained on material science would not lay such claim. In the first instance, this is my area of specialty. Let us first of all understand what is meant by tensile strength. We have what we call ultimate tensile strength, which is the maximum stress which any material can withstand before it breaks under tension or tensile loading. That is, if you stretch a material, it gets to a point that it can no more bear and it breaks. That is the ultimate strength of that material. Now, that of steel, of course, you know we have 2 types of steel, mild steel and high yield steel. Mild steel ranges between 400 to 550 newtons per millimeter squared or megapascal. Whereas for high yield steel, it ranges between 500 and 1,700 newton per millimeter squared, depending on the type and grade of steel. Whereas bamboo has just 52 newton per millimeter squared or 52 megapascal. That is in terms of ultimate tensile strength. Now there is still another one which we call yield strength. That is the strength or stress at which a material changes from elastic state to plastic state, resulting in a permanent change or deformation. What that means is that if you drag any material, it stretches like maybe dragging a rubber band. At a point, it will not be able to go beyond that point. Ordinarily, we call that state elastic limit. Now, we were made to know or understand that after elastic limit, that material will break. No, that was just at that level when we were in the secondary school. That was what we could bear, our capacity. But the real thing is, after this elastic limit, that material now enters another state, which is called plastic state. So the point at which it changes from elastic state to plastic state, whereby you drag it, it cannot stretch and return if the force is removed. It keeps stretching, but it can't return again. That is plastic state. It is undergoing plastic deformation. So that point where it starts to experience that is called yield strength. So now mild steel has 250 newton per millimeter squared, whereas high yield steel ranges between 400 and 460 newton per millimeter squared. So many engineers adopt 410 to be on the safe side. Personally, I use 410 in my designs. Some engineers use 400. Now, bamboo has between 50 and 120 newtons per millimeter squared. That's 120 megapascal. But on the average, if you ask any engineer, he would tell you the yield strength of bamboo is about 50 newton per millimeter squared. But just like steel, it depends on the species of the bamboo and the age of that bamboo and many other factors. Of course, when we talk about bamboo, you need to realize that we have bamboo as grass and bamboo as tree. That's talking about raffia bamboo and Indian bamboo. That's the one with hollow inside. That one is from the grass family. Whereas the one from raffia palm tree, that one is another species. But all of them put together, their strength, yield strength, ranges between 50 and 120. Now, there is another one which brings about this misconception. That is what we call tensile strength to weight ratio. This is where people say the strength of bamboo is greater than that of steel. But let me break it. We talk about density. The density of steel is about 7,800 kilograms per meter cube. whereas the density of bamboo is just 800 kilograms per meters cube. Now, we have stated that specific strength, which is this tensile strength to weight ratio. Now, that is the ratio of the strength, the yield strength of steel to the density of steel. The same thing as the strength of bamboo to the density of bamboo. Now, if we have to do this calculation, we take on the average that the yield strength of steel is 400. Now, if we divide that by 7,800, which is the density of steel, that will give us about 51 Newton millimeter per gram. Whereas that of bamboo, if we take 52, which is the average, and divide it by the density of 800, it will give us about 65 Newton millimeter per gram. So it is here that people assume that that of bamboo is higher than that of steel. No, this is not the ultimate tensile strength, and this is not the yield strength. Rather, just a relative strength. That is the ratio of the strength of one material to its own density. That factor is only considered when we see weight as a parameter to be considered. But in this instance, it doesn't give us any advantage, so it doesn't come in at all. Now, why we have to emphasize this is that because of this mix-up, people have used it to do deckings, they've used it for large span beams, they've used it for columns. This is quite deadly. The available literature shows that bamboo does not have this higher strength as claimed by people than steel. In fact, with the permission of Professor Charles Oko, he's a professor of material science. In his research in this same area, he showed that the only advantage that bamboo has over steel is in terms of weight. It is lighter. Whereas the same research concluded that there is need to incorporate these parameters of bamboo if extensive studies are done that are conclusive, then the parameters of bamboo should be incorporated in design codes so that engineers will be able to use those parameters in structural designs. But without that, we cannot do anything. But like I said before now, I am studying this. So I'm not against the use of bamboo. Yes, I believe in sustainability in construction. I believe in sourcing locally made materials in construction. I'm even advocating for it. But I'm telling us that we must set the limit to which we can use this material. Bamboo has a lot of limitations apart from a characteristic of strength. We talk about interfacial bonding. That is the interaction between the concrete matrix and the reinforcement fibers. That is a challenge on its own. Then the issue of durability, the issue of insect attack or fungal attack. These issues have not been sorted out, but there are many researches, even ongoing, which I believe with the support of government and individuals who are interested in this, companies, we will be able to come up with substantial facts so that we can start using. But for now, we can continue to use them in lightweight structures, not in heavyweight structures. No, of course, that Professor Charles Oko's research stated that, and it's even what my project also advocates. But I must admit that in China, in India, that these bamboo materials have been used in construction. But the limit to which they have also used, we cannot ascertain for now. So I don't know what your comments or your thoughts are. Please put down your comments in the comment section and also share this video. Give us the likes to encourage us.